to unit circle. All right. You guys dealt with this a little bit last year, and so we're going to be doing it again, but I'm going to hopefully teach you some techniques that it will stick. All right. I promise you by next Tuesday, it will be in there. I promise you. All right. If you do what I'm going to ask you to do, it will be in there. I promise. All right. I've been doing this a while, and I've been teaching. This is what I want you to think of. A unit circle has all of these things, but a unit is because its hypotenuse is always 1. That's really what's happening. And then we have a y value and an x value that happens, and then you can use Pythag to get a unit of 1 for the hypotenuse. That's what's going on. But this is what I want you to write down. Whenever you think of sine, usually in sine you think of opposite over hypotenuse, true? However, the opposite is the y value. The hypotenuse is 1. So it's just going to be the y value. So sine, I want you to think of as y.
Yes.
Cosine,
X.
I want you to think of as x. All right. Cosine is usually adjacent over hypotenuse. Well, the adjacent side is going to be your x. All right. Tangent, you usually think of opposite over adjacent, but I want you to think of tangent as y over x.
Yes.
All right. Does anybody remember who sine's buddy is?
Cosine.
Cosecant. All right.
Oh, cosecant.
So cosecant is sine's buddy. And the way that I want you to think of it is I want you to think of it as the reciprocal of sine. Now, the way you write a reciprocal is 1 over y, but that's not really how I want you to think of it. I want you to get sine and then flip it. All right? Because that's what a reciprocal is, right? Cosine's buddy is who? Do you remember? Secant. And the way that I want you to think about it is it's the reciprocal of cosine. All right? And then tangent's buddy, do you remember it? Cotangent. I don't want you to think of it as the reciprocal of tangent, even though it is. I want you to think of it as x over y. Okay? So, let's quickly review. When I say sine, what do I want you to think of? Y. Cosine? X. Tangent? Y over x. Who's sine's buddy?
Cosecant.
Cosecant. How are they related? They're reciprocal. I don't want you to think of it as 1 over y. That's the way you kind of write it. But I want you to think of it as the reciprocal of sine. Who's cosine's buddy? Secant. How are they related? They're reciprocals. Who's tangent's buddy? Cotangent. And how do I want you to think of it? X over y. All right, let's put this into place. So this first angle we have is pi over 6, and we're going to evaluate all 6 trig functions at pi over 6. Go ahead and look on your little unit circle and find pi over 6. Did you find it? What are the coordinates of pi over 6? Comma 1/2. All right, does everybody see it on the unit circle? I want you to use your unit circle right now. Okay? I don't care about you memorizing it right now. Is everybody hearing me? I want you to just use it. All right? Soon we will start memorizing it. All right, but right now, just use it. Now, sine of pi over 6 is just, what do I want to think of with sine? It's just the what value? The y value. So what do we get? We get 1/2. And then cosine of pi over 6. Cosine of pi over 6, I want you to think of what? The x value. So what is it? Square root 3 over 2. All right. And then tangent of pi over 6 is what? 1/2. So the y over the x. So it's square root 3 over 2. So what happens here? The 2's cancel. And then I'm left with 1 over square root 3. However, what's wrong with that thing? It's not rationalized. So we need to rationalize it. So when we rationalize it, we multiply by square root 3 over square root 3. That's really what's happening. So what do we get up top? We get square root 3 over 3. And then sine's buddy. Who's sine's buddy? Cosecant. How do I want you to think of cosecant? The reciprocal of sine. So sine is 1/2, and the reciprocal of 1/2 is 2. And then who's cosine's buddy? Secant. And so secant, how do I want you to think of it? The reciprocal of cosine. So this is really what? 2 over square root 3. Now, what's wrong with this? It's a square root on the bottom. So I rationalize it. So what does it become? 2 square root 3 over 3. And then who's tangent's buddy? Cotangent. How do I want you to think of cotangent? The x over the y. So what's the x? Square root 3 over 2 over the y of 1/2. So what happens? The 2's cancel. I'm left with square root 3 over 1, which we can just call what? Square root 3. Okay? I'd like you to do 5 pi over 4. 5 pi over 4. What quadrant was it in? It's in the third quadrant. And this is negative square root 2 over 2, comma, negative square root 2 over 2, right? So sine deals with the what part? The y. So it's negative square root 2 over 2. And then cosine deals with the x. So it's negative square root 2 over 2. And so tangent would be what? Y over x, which is just 1. Okay, because they're the same thing over each other. And then cosecant. How do I want you to think of it? The reciprocal of sine. So now I end up having a negative 2 over square root 2. But what's wrong with it? It's not rationalized. So I rationalize it. So I multiply by square root 2 over square root 2. And now I'm left with negative 2 square root 2 over 2. So what happens? The 2's cancel. So I'm just left with what? Negative square root 2. And so secant, how do I want you to think of it? It's the reciprocal of cosine. So you flip it, and what do you get again? Negative square root 2. Cotangent, how do I want you to think of it? Your x over y. However, they're the same, so what do we get? We just get 1. This one we're going to evaluate at 0. So I want you to find when theta is equal to 0. You see it on the x-axis, your beginning initial point. So what is it? It's 1 comma 0. All right, so that's what I just want you to use the unit circle. So now if I do sine of 0, I use the what value? The y value. So what do I get? I get 0. All right, so cosine is 0. Cosine, I want to deal with what? The x. So what do I get? 1. And then tangent. How do I want you to think of tangent? The y over the x. So I get 0 over 1, which is 0. Now, who's sine's buddy? Cosecant. So now cosecant of 0, what do I want you to think of it as? It's the reciprocal of what? Sine. It's the reciprocal of sine. However, sine is 0, which is the same thing as 0 over 1. You following me? If I flip 0 over 1, what do I get? I get 1 over 0, which we call undefined. So cosecant of 0 is actually undefined. And then cosine. Who's cosine's buddy? Secant. How do I want you to think of it as? It's the reciprocal of cosine. So what do we get? We get 1. And then tangent's buddy is? Cotangent. How do I want you to think of cotangent? Your x over y. So what do we get? We get 1 over 0, which we call undefined. All right? All right, I'd like you to do the 6 trig functions at pi over 2. All right, so pi over 2, what's its coordinates? 0, 1. So sine deals with the what value? The y. So I get 1. Cosine is the x, so I get 0. Tangent is y over x, so what do I get? 1 over 0, which we're going to call undefined. Cosecant, it's the what of sine? It's the reciprocal, so what do I get? 1. Secant is the reciprocal of cosine, so what do I get? It's undefined. Very nice. And then cotangent. How do I want you to think of cotangent? X over y. So what do we get? 0 over 1, which is 0. So this next one, we're going to evaluate all 6 trig functions at negative pi over 3. However, look for negative pi over 3 on your unit circle. Is it there? It's not there. Daggone it. I need to find a coterminal angle to it. Well, how did we find coterminals? We add 2 pi to it. So if I add 2 pi, I'm really adding what? 6 pi over 3. That's really what I'm doing. So when I add 6 pi over 3, I get what? I get 5 pi over 3. Now, can you find 5 pi over 3 on your unit circle? Yeah, you can. So what are my coordinates of 5 pi over 3? 1/2, comma, negative square root 3 over 2. All right. So what quadrant was that in? It's the fourth quadrant. All right. So we had a positive x and a negative y in the fourth quadrant. All right. So now when we're evaluating these, I have negative sine of negative pi over 3. Yes, I'm still going to write negative pi over 3 because that's what I'm being asked to do. However, how do I actually think of it? I actually think of it as 5 pi over 3. All right? Even though it is really negative pi over 3. So sine deals with what? The y. So what do we get? Negative square root 3 over 2. And then cosine deals with the what? The x. So what's my x? 1/2. And then tangent. Tangent deals with what? My y over x. So I have negative square root 3 over 2 over 1/2. But what happens? The 2's cancel. So what am I left with? Negative square root 3. All right. And then sine's buddy is cosecant. So I have cosecant of negative pi over 3. And how do I want you to think of it as? It's the reciprocal. So what do I get? I get negative 2 over square root 3. And you guys are going to get really good at rationalizing in your head. I know you will. So what does it rationalize to? Negative 2 square root 3 over 3. And then who's cosine's buddy? Secant. So now I have secant. And how do I want you to think of it as? It's the reciprocal of cosine. So what do I get? Just 2. And then cotangent is tangent's buddy. How do I want you to think of cotangent? X over y. So what's my x? 1/2 over negative square root 3 over 2. So my 2's cancel. But what's wrong with this right now? It's not rationalized. So what do we get? We get negative square root 3 over 3. All right. Now we're going to talk about the period of a function. So the period of a function of sine and cosine is 2 pi. So I have sine of 13 pi over 6. Bless his heart. I have sine of 13 pi over 6. Is 13 pi over 6 on my unit circle? No. So what do I have to do? I have to subtract what? 12 pi over 6. I need to use its period. So I subtract 2 pi over 6, and I end up with what? I end up with pi over 6. So I'm basically doing sine of pi over 6. That's really what I'm doing. Now, is sine of pi over 6 going to be on my unit circle? Yeah. Sine deals with what? The y. Sine deals with y. So what do we get? We get 1/2. So even though I evaluated 13 pi over 6, the sine of it, to get 1/2, I really thought of its period that was before it. You following me? Because it's the same every 2 pi, or a month in Kate's case. All right? Here we go. So now I have cosine of negative 7 pi over 2. All right? Is negative 7 pi over 2 on my unit circle? No. So I need to use the period. So what do I need to do? I add 2 pi. All right? I add 2 pi, and what do I get? I get negative 3 pi over 2. Is negative 3 pi over 2 on my unit circle? No. So what do I do again? I add another 2 pi. So what do I get? I get pi over 2. Now, is pi over 2 on my unit circle? Yes. So that time I had to use how many periods? 2. All right, 2 cycles. 2 cycles. All right, so now pi over 2, what's the cosine of it? 0, because cosine deals with what? The x. All right. Now I want to make sure you guys know how to use your calculators. Make sure you're in radian mode. So sine of 2 pi over 3, you put that in your handy dandy calculator, and hopefully you get that. Cotangent. Do you have actually a cotangent button on your calculator? Say no. You don't. All right. I want you to do 1 over tangent of 1.5. All right. I want you to do 1 over tangent of 1.5. For instance, if I had to do cosecant, cosecant would be what? 1 over sine, right? So just make sure you can use your calculator. Make sure you get the right responses. All right, the calculus teacher told me that this unit circle is important. All right.